Okay, sorry for the crappy audio. I'm throwing this together on no notice. So I've got a bucket heater that's 1500 watts, supposedly a little portable heater that's supposed to be 200 watts. That ended up adding up to a better number than using the big portable heaters. So, and then over here have 20 amp circuit with a voltage and current monitoring clamp, and then a voltage monitoring inline here. It's 12 gauge wire. The gray meter is measuring the power coming out of the wall. The yellow meter is measuring the power going out the far end so that we can observe the drops. And to not totally overheat, I'll be using a thermal camera to just babysit the temperature of the cord. Right now it's at 70 degrees. It's been just chilling here. I don't think that's a focus. Chilling here on the shelf. So let's see what happens here. I'll try and zoom this over so that you can see the more interesting bits. There we go. And it should be pretty apparent once I plug things in which load is which. So, here is the bucket heater, or which voltage is which. And here is the portable heater. And we're up at 12.5 amps. So the wall is down to 119.6 and the output is down to 114.3. And this is on a coil spool at the moment. So far not getting warm yet. It's getting warm but not getting above room temperature warm. So I'm hanging at 12.6 amps, so that's a good thing. So I'll let this go for a minute just to be able to observe. Interestingly, the plugs might be the limiting thing that I get nervous and unhook, and these current monitoring clamps. So this is currently 0.5 minus 114.5. So that's 5 volts drop. Yes, I know I left the meter on. That was intentional. And in this couple of minutes, the cord's up to 71.5 versus the ambient temperature of 69.5. So it's like 2 degrees change. And it's just in a spool. So, the next thing to do here will be to unhook all this and lay the cord out in a straight line. And I will be right back, and then we can determine what the oops. Yes, I know the meter was left. Then we can determine what the difference is between a cord that is coiled up and a cord that is not coiled up. I'm just going to go for the extreme differences here. This is a very heavy cord. Like weight-wise, I don't want to have to wrangle it into a figure 8 and back. So, let me run this around the basement in a straight line. Okay, so I now have all 100 feet as much in a not looped straight line as I possibly could get them. So, my expectation, maybe I'll be surprised, is that the numbers will be approximately the same as what they were in the previous test for the loss, because I don't think there will be any inductive heating losses. The idea is that if the voltage is different between the tests, then the energy is lost in a different way. Energy can't be created or destroyed. We know the current we can measure is the same. So then the only question would be whether all the energy is lost in the same way. So, just forgot to put my monitoring probe thing here. And this is a lot harder to balance now that it has no cord weight. And like before, I'm going to do the gray meter going up to the wall. Come on, meter, turn back on. There we go, 20 amp scale. And this is going to come up to here. This has a little coil I want to eliminate as much as I can. And now I'll plug these into here. Try and get these set up so they're easier to read on camera. Okay, are those in frame? Sorta, kinda. There we go, that's more readable. So, voltage is the same. Now we'll plug in our load. We are now up to, interesting, only 8 amps. Why are we only getting 8 amps now? That's not the outcome I expected. That's not at all the outcome I expected. Oh, my meter was... There we go, 12.5. My meter was at a funky angle and it wasn't properly clamping. Yeah, 12.4 amps. There we go. That's what it's supposed to be. Incorrect meter position. 12.4 amps. I'm going to call that close enough to the 12.5 amps we had before. Our previous readings were 119.5, 114.5 for a drop of 5 volts. Our current readings are 118.9 and 114 even. Which is 0.9 minus 1. Now it's 113.9. Which is also exactly 5 volts. So if there is a difference at a 12 amp load with a 100-foot 12 gauge cord, if there is any difference, it's only like 0.1 of a volt, and that's within the error of these multimeters. So I am going to have a hard time buying the argument that there is more loss if it is in a spool coiled up the same direction versus stretched all the way out. I don't know what other explanation, but since there was no difference in the readings for the amount of lost energy, then the energy couldn't have been going elsewhere. And just for kicks, 12.3. 12.4, yeah, the same amount in, same amount out. Whoops. And now I'm having loose connections develop as I wiggle stuff around. And it's much harder now to measure the temperature of the cord, but still, the limiting factor by a huge margin is actually at the plug there. And also at the plug down here. It's not along the cord with a heavy 12 gauge cord, at least. So I think that concludes my interest in this test, and I am reasonably satisfied that I do not believe there is a difference.